Hello students, let us learn how to find bandwidth of an amplifier. That is, how to find bandwidth of an amplifier. Now, very important point is what is a bandwidth and how to find out a bandwidth. So what is a bandwidth? We are going to learn it later. First, let us learn how to find bandwidth. So to find a bandwidth, we need to do a small experiment. So from that experiment, we need to get some values, we need to tabulate it, and we need to plot it on a graph. And once the graph is ready, we can find out a bandwidth. Now let us learn how to do that experiment and how to calculate the bandwidth. First, let me assume I have an amplifier. It may be any amplifier, it may be CE amplifier, or it may be CC amplifier, or it may be CE amplifier. It contains two input terminals and two output terminals. So, an extra information, the pair of terminals is called port. Pair of terminals is called, what is that? Port. A pair of terminals is called port. P-O-R-T, port. Okay. And an input, we call this as an input port and we call this as an output port. The voltage which is applied at the input terminal or input port is input voltage. The voltage which is available at the output terminal is nothing but output voltage. So now, then the gain of this amplifier AV, that is voltage gain, is given by output voltage divided by input voltage. Now, it is just one extra information. Now, in this experiment, what to do? First, let us fix up the input voltage to 50 millivolt. I'm taking this value because in your college also, when they conduct an experiment called CE amplifier, they consider the input voltage as 50 millivolt only. So for that reason, I took this value. First, fix up the input voltage to 50 millivolts. That is, if this is your input signal, then its peak to peak voltage. We call it as VPP, which is nothing but VI, and fix this to 50 millivolt. See, the height of the wave is constant. Now what you need to do is, you need to vary the width of the wave. So the width of the wave gives us the time period of the wave, or time period of the signal. And we all know that 1 by time period is frequency. So here what we are going to do is, we are going to vary the frequency of the signal. Let us vary the frequency of the signal, which is measured in hertz, okay, and note down the corresponding output voltage, which is measured in volt. So what you need to do is, first, we fix up the input voltage to 50 millivolt and we keep it constant. And we are going to vary the frequency of this input signal initially in steps of 100 Hertz. First, I fix the frequency of the input signal to 100 Hertz and I'll note down the output voltage. I'll measure the output voltage and I'll note down the output voltage. And after that, I raise the frequency to 200 and I'll note down the output voltage. Similarly, every time I'll increase the frequency by 100 and I'll note down up till 1000. And even when the input signal frequency is 1000, what is the output voltage I am getting? I am going to note down here. So after 1000, I'll start varying the frequency in steps of 1000 Hertz. So that means the next trial will be 2000 Hertz and I'll note down the output voltage. After that, 3000 Hertz, etc. up to 10K. K in the sense 10,000 Hertz. 10,000 Hertz. Once for 10,000 Hertz, I'll note down the value. And after 10,000, I'll vary the frequency in steps of 10Ks only. So next value will be 20K. Then next is 30K, 40K, etc. up to 100K. After 100K, I vary the frequency in steps of 100Ks. That is, next trial will be 200K. And I'll do this up till 1 mega. For every frequency, there will be an output and I'll note down this output in the column. And once the values are ready, I calculate the gain, which is given by VO by VI. So whatever the output voltage we get it here, we divide this output voltage by this fixed input voltage. Once we do that, we get an output voltage. So for every trial, I am going to calculate the gain. Once the gain is ready, then I am going to plot a graph by considering frequency along the x-axis and gain along the y-axis. And I get a graph somewhat like this. In this graph, we consider this value as AV max, that is the maximum gain of the amplifier. And if I divide this maximum gain by √2, I get some value. From that value, I draw a horizontal line that touches the curve at 2 points. Where I get two cutoff frequency. First one I call it as a lower cutoff frequency F1. Second one I call it as an upper cutoff frequency F2. And if I take the difference between the two cutoff frequencies, then I get bandwidth. That is F2 minus 1. So this is the bandwidth. And this is how we calculate the bandwidth of an amplifier. Now, very important point is, why do we need to calculate bandwidth? Why do we need to calculate bandwidths? See, by calculating the bandwidth, we come to know the range of frequencies of the input signal when applied to an amplifier gets amplified to the almost maximum extent. So what I am trying to say is, ನಾವೇನಿಲ್ಲಿ ಇನ್ಪುಟ್ ಸಿಗ್ನಲ್ ಅನ್ನು ನಾನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಅಪ್ಲೈ ಮಾಡಿರುವ ಇನ್ಪುಟ್ ಸಿಗ್ನಲಿನ ಫ್ರೀಕ್ವೆನ್ಸಿ ಈ ರೇಂಜಿನಲ್ಲಿದ್ದರೆ ಆ ಸಿಗ್ನಲ್ ಆಲ್ಮೋಸ್ಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಲೆವೆಲ್ಗೆ ಆಂಪ್ಲಿಫೈ ಆಗಿರುತ್ತೆ. ಸಿ, ನೀವೇ ಈ ಗ್ರಾಫಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ಇನ್ ದಿಸ್ ಗ್ರಾಫ್, see, if you apply a frequency of around 100 Hz, the gain of the amplifier will be only this much. For 200 Hz, it is increased. For 300 Hz, it is further increased. But like that, see, after some particular value, the gain becomes constant up till some other particular value. And after that, once again, gain decreases. So now, for some range of frequencies, the gain of the amplifier is maximum. And for some range of frequencies, the gain is almost more than 70%. And we call that range as bandwidth. Thank you.